Okay, so in another video, I presented a proposal for an initial experiment for testing whether we might be able to teach orca's language. And this video is sort of a small appendix to this video where I quickly present another experiment that I would be excited about testing. And this is about like teaching orcas basic math. And why would I be interested in that? Because for language, it's like maybe humans have particular innate machinery for learning language, and then maybe it's very hard for orcas without the same machinery for learning language to learn language that is still sort of human-like. Whereas for math, it seems much less likely that we have like very much innate machinery for learning it, and then maybe orcas can learn math the same way as humans, and if they are sufficiently smart. So this would be some other angle of getting evidence for whether they are pretty smart or, yeah, even if the language thing might fail, we don't know. So yeah, the like the previous video is important as context. We still use the same letters like sounds in this video, and we have two new letters which are just like higher sounds, the next higher sound G and the next higher sound A. And yeah, so first, what are the number words? Like they have a very regular pattern. You can observe the pattern here. So like here we have 0. It's just like we always have this first the high A as like the first letter in a number word. And then we have like 0, this, 1 is this, and so on until 5. 0, 1, 2, 3, 4, 5. It sounds like this. Only actually it's all one octave higher. I just couldn't quickly set tones an octave higher here. But yeah, and then like for the numbers 6, 7, 8, and 9, we have them look like this, which is also pretty regular. It's sort of like the pattern is sort of like having a 5 here and then a 1, 5, 2, 5, 3, and that's of course like 6, 7, and 8. And yeah, and again, or like not again, but those are just the words for numbers. It's just like structured in that way that they can maybe recognize the patterns and more easily learn the words for numbers. But in the end, it's like really not at all important that they recognize the pattern. In English, we have like 1 and 2, and the words themselves don't have any similarities. This here is just a property that it's even easier to learn the words for numbers. And then from 10 on, we just uh, like append digits together to get the numbers. So 10 is just like 1 and 0. 11 is 1 and 1. And like it's just as if the word for 11 in English would be 1, 1. Very simple. And this is like all the next numbers are like work similarly. Okay, so how might we go about teaching numbers? Easy. Or like whether it can learn it is not clear. But like the methodology is just like we take two balls, put them into the water and say two balls. Then we put one out and say one ball. Then we put two in and say three balls. And then we do the same for hoops. And then we can see whether it can recognize the pattern of like, oh, okay, wait. So now we have two hoops again in there, and then we ask what hoops, where the what word is always the fill in the blank word, and then they are supposed to say two. And yeah, like if they don't get it correctly, we can of course use our supervisory signal, the tin whistle, to say you should have said two, basically, or like just demonstrate two. And And yeah, like we can also use more objects and can check whether they can generalize to new objects they haven't seen before, where we then have like two new objects like a coin or so to put two into the water and see like what coin, and then they are supposed to say two coins. And we can do that for 3 and 4 and 5. And yeah. And yeah, then we can also try counting, where we always add one ball or so to the collection of balls and always ask like how many balls, and then they might learn the pattern, or like get a better sense for the order of like 1, 2, 3, 4, 5, 6, 7. Um, yeah, and now it gets interesting, like addition, how might we go about teaching that? One approach would be that we just like put one ball in on one side of the pool and one a few meters on the other side, and we like put this in and say like one ball and then plus one ball, and then we put them together and say like is two balls or so. And then we do that again for like hoops, and maybe two balls on this side plus one ball on this side, three balls, and like having this merging together thing, so we can sort of ground the function of what addition means in like, okay, um, like you are supposed to take this set and you're supposed to take that set and merge them and look at how many elements are there. And yeah, then we can also try to check whether they can like complete that, where we now take a new object, one coin there and one coin there, and say like, is how many, is like what coins? And then they are supposed to say two. And we can do that with more examples of like 2 plus 3 and so on, 2 balls plus 3 balls. And then once they got that, we can try to drop like we can first try to drop the demonstration, where we just say abstractly like 2 balls plus 2 balls is what balls, and then they are supposed to say four, and if not, we can always say like four would have been the right answer. And then we can even like drop the object name, like ball, and just like say the abstract statement of 2 plus 2 is 4. And then we can ask them, okay, what is 1 plus 3, and so on. And yeah, then last, we can also try whether they can complete simple pattern recognition tests, where we just like give them some sequence, 4, 5, 6, and then ask to what word, and then like they are supposed to say 7. Can again demonstrate that with a couple of examples, and then we can check whether they can like complete even more difficult sequences like 2, 4, 6, where they need to recognize, oh, the distance is always 2. And like this is hard. Like generally, like hunter-gatherers are probably not even that good at learning math. Like we would need to compare that they aren't going to be like super good at math, like we in our civilization just learn math from a very young age with a lot of time and are very good at it. But like this is actually hard if you've never seen math. I wouldn't expect like humans who have never seen math to be good at this, like from our perspective. But yeah, it would be interesting whether they can do it at all. Like it's possible that they can't. And yeah, like of course for this whole thing we need to uh, check that they don't just like memorize some patterns, but actually like check whether they can like complete some new uh, like prompts which they haven't seen before, where we then have like 2 plus 5 they never seen before, and they should still correctly show 7 and say 7. And yeah, so I think no animal has shown this capability so far, generalized addition. And yeah, would be interesting whether they can learn it. And yeah, like if one is super optimistic, you could like also spend more time on like then teaching even more math. But yeah, I guess the addition thing would also be already be pretty impressive and interesting, and would give us a lot of information about how long it took, whatever. Yeah.